So, in the previous lecture, we went over a little bit of ROS. Let me get this back up. Okay, so we learned a little bit about the topics and nodes. So if you remember topics, what are they? We got a quiz right now, what are they? If I change the slide, what are they? Okay, so topics are data streams that you want to use between two more programs. So if you want the camera topic from the robot, which I'm going to show you very soon, then you would just say, I want that topic with that particular name. So I'll show you that exact example in a second. So topics are the data streams that you want to use between two more programs. Nodes are the ROS programs that you create. Three-second lag in this program. Okay, so given that, what are the blue circles and blue ovals? Nodes. And what are these lines? Topics. Okay. The graph that you can see in ROS is actually much nicer than this. It looks like the slides that I showed last time. And what I want to show now is actually some robot control using Python. So I'll show you the program on the robot first. Show you what it does, and then show you the robot doing it, of course. So the first example I'm going to show is the robot control with Python. Next one's going to be C++ and Python, two different versions of the same thing. And then a slightly more advanced image processing routine using C++. Just longer, uglier code, basically. So, more into the command line. Let me see if I can change this to where we see the same thing. And increase the size. You guys read that? Bigger? Is that too much? Okay, so there's where we're at right now. So this robot is called Kabuki. Okay, it's a robot. Most likely, these are probably not going to be used by most people in the class unless they're doing a little bit of slam. So the slam guys are probably using these. Do a little intro to it. It has a bump sensor. It acts a lot like a Roomba. It drives around on its two tires, 22 wheels. I'm not sure if you guys have gone over differential drive robots yet. No? Okay. So it has two wheels, it has two rollers, two caster wheels. It has a battery in here. There's charging connectors for the charger. And it has some infrared sensors so it can find the base. And on top of that, we put an Asus XTI-line camera, which has the RGB-D color in-depth camera. And there's an Odroid XU4 computer in it. And of course, Wi-Fi, but knowing that I didn't bring my own router, and last time I tried that, it didn't quite work. I brought my own network cable. So, we use that command history, which I told you guys about. Of course, this one has not done anything yet. So, I had it here somewhere. Another little trick with Ubuntu is that whenever you close all your terminals, you get your history all in one place. So here's a command that you really need to know. For those that don't know Linux history, it's really wonderful. It'll show you everything you've done in the past. So there's a whole bunch of things I typed in so far today after installing Linux on my computer. So if you want to filter that list for particular information that you want to extract, you can use this command called grep. And this vertical bar is the pipe. So if I tell you to pipe the output of history to a grep searching for SSH, you may want to know what that is. So I may even give this as part of the homework assignment. So here's how you filter to figure out what you've connected to. So probably also be useful for a hacker. Okay, so if you want to recall one of those commands that you already made, say SSH to the O drive, which is the O drive, at whatever its IP address was. Let's just do that. You can recall the command using the exclamation mark and then the number. So right now I just typed in SSH O drive at 10.4 whatever, and I hope that we are connected. I would probably check it real quick. Should be okay.
And always remember your password.
Yes. So if you ask us what your password is, what I'm going to tell you. I have no idea. Alright, so luckily I brought the cable I need to repurpose it. I had this working in the lab and I reset the robot number of times, that didn't work. So hopefully it works this time. So now you can see the boot up of the device. Nobody has a spare keyboard? One thing I bring.
You need keyboard?
Yeah.
Can you take that one?
No, really.
You should have. You're good.
Okay, so same time, I guess we're waiting for the keyboard. I can show you the example I'm going to get from ROS. Okay, so whenever you look for a package, what you're going to do is look for what you can see about it. Like I told you last time, we're looking at indigo. So when you land on this page, what can you figure out? Not much of anything. So Vision OpenCV is the package, is the meta package that these packages are in. It's the collection of CV Bridge, Image Geometry, and OpenCV apps. So if you look at this little gray box off to the side, tutorials. Sometimes it's there, sometimes it's not, sometimes it has stuff, sometimes it doesn't. So usually you're screwed. But sometimes you actually get good examples. In this case, you actually get Python, C++, and Android Mobile. And I'll be able to show you these now. So the Python one, the one everyone wants to look at, is this one. So you can convert between ROS images and OpenCV images. And again, there are some very nice gray boxes that show you what's all going on in the code. And most people probably don't have to mess with this, but for those lucky ones that do, there are many different ways to represent an image. And unfortunately, I've gone through just about all those trying to figure out how to make the depth work on the Connect in terms of an image. So if you're trying to use a depth image, you may want to come to me first and get some help, because I've gone through all the different combinations. So, to see a little bit further here, when you go through all the tutorials, this will actually make sense to you. You create a file called your package manifest, which you have to update with the different packages that you have in it. And that would include for this node, sensor messages, OpenCV to CV Bridge, ROS-Pi, and standard messages. Those are all different other packages that this node depends on. When you get into it in the code, you'll see that this code is actually pretty short for what it does. It actually would fit on one page of my computer on the screen. So what this whole chunk of code does is it makes a circle on an image. So the part where it actually brings in the image is inside the callback, as we talked about last time. You have to register a, so at the very beginning of your ROS code, you would state that you have a program which needs to be into the ROS ecosystem. It'll be called image topic. The topic itself will be called image topic 2. It'll be subscribing to image topic. You can change its name to make it be whatever topic you want it to be. You could call your image topic and the other one image topic 2. You're up. That's not very descriptive though. You want to give it a good name so you know what you're talking about. So the subscriber sets up the link inside a ROS. So all you have to do to get your images into your program is subscribe to them, and then process them with this function called callback. And then right here is where you actually state that the function called callback will be used. So when you get an image, which is a ROS image type, you have to convert it to an OpenCV image type to process it. Because OpenCV is the API that you would use to process images. It's the most widely used API as well. So if you want a job in image processing, you probably want to learn OpenCV. It will really help you. So you open the image as an OpenCV image from the data stream that you get from ROS, and you have to open it with BGR8. And then this code right here creates a circle on the image. It doesn't create it anywhere special, it just creates it one particular point and just lays it there. The circle you could use as like a thing for you, like a little object for you to identify where the feature was that you're looking at in the image. You can make a circle over, you can make a line pointing to it, arrows, whatever you want to do. Circles are easiest. And you can highlight the shape, whatever it is that you know. And then you can show the image using an OpenCV window, or you can show the image using a ROS image view window, which I plan to show you in just a few. And I actually have this code on the robot so I can show it to you with the camera as well. So let's see if we can get this going so I can use the laptop to show both things. So most likely whenever you guys use a networked robot, the first thing you're going to learn is ifconfig. It means interface config. So it shows that we should pretty much have connection. Well, of course right now, it just worked. You plug in the keyboard and then the thing works. So the issue we were having before finally cleared up. Okay, so this is not needed anymore. For now. And we can switch back to the main screen. Which is better. Okay, so right now we're inside of the Kabuki computer, the Odru. So here's the file I was trying to make sure it had run beforehand, so maybe it was just taking a while to complete. But that actually sets up all the wireless capabilities and wire capabilities. So, when you go through the tutorials, you're going to find that there's something called Catkin. Catkin is your code manager program. It's a lot like Make, for those of you that know what Make is, or CMake, which is like a manager for Make. So Catkin is like a manager for CMake. So inside of the Catkin workspace, which is the Catkin WS, which you'll see in the tutorials, you put your code. So there's a few different packages that we actually already have worked on this robot. One of them's called Kabuki Controller, another one's called Feature Tracking, and another one, not successful yet, but it's called Robot Upstart. So earlier, so to create another window, which you're going to need to do anyway, you would use extern. First you have to log in with the permissions to actually use the external. And all that really does is create another window that you can use. And of course, it's not going to be the exact same type because it's actually an external window. It's not a regular terminal window. And okay, I'll just tell you what I'm doing on this one. So right now I'm starting the Kabuki software. Anybody who needs to work on it, you can come see me. It's not critical on this part. So you can hear the Kabuki.
You type ROS launch before going to, right?
Yeah, this is what I typed.
Yeah.
So this is a ROS launch command. ROS launch the Kabuki node with the file, which has the settings. The file itself is called minimal.launch. These are just standard things you have to type in to make your programs work. If you make your own launch file, you'll be putting your own name instead of minimal. You'll be putting, Barat.launch or whoever.launch. It just has the settings that you want for that particular program. So we also need to okay, so whenever you exit the terminal, that's another good lesson. Not what I wanted to use the memory for. So that one was the Kabuki node again. So when you close the terminal, you lose everything. So you decide, let me just log off the robot before it goes and does its thing. Bad idea.
Just open any window maybe?
Yeah, that's what I did. So instead of exiting, I just open another window. This one is ROS launch, open NI2 launch, open NI2.launch. You can use tab to complete most of what you're typing in. It really helps. Makes your life a lot easier. The node that I'm particularly interested in right now would actually be the one right here, color tracking rg.cpp. You can name the program whatever you want in another file, which you learned about in the tutorials. But I just want to show you how.
Sorry.
So here's what I want to run in another terminal. I do have to open up another terminal to show you what the output is. But this is actually going to do some color teacher tracking. Let's do the Python one first, I guess. The color tracking. It's not actually even color tracking. This is just that circle I told you about. So OpenCV windows, you can't really do much with them. You can't resize them. You have to open up at a particular size to do anything with it. That's why I don't like them. But you can see right there, up in the little corner, there's a blue circle. That code that I showed you draws that blue circle. But it also gets the image data. And that's freely available. So the blue circle is the only thing that stays in the picture, and it's really doing that. Maybe we can hit Barat with it, I'm not sure. Let's see. It's going to take forever. So the blue circle is not really worth anything. It would be good if you use that as the output of your programming, your processing for an image. So say you want to find a particular person. There's actually face detection in OpenCV that you can use right out of the box. You can say, okay, I found all the faces in the room, hopefully. Maybe some people in the back or maybe the front, if they're too close, they won't be seen. But you can easily do face detection. And then you can highlight all the different faces and maybe you can figure out who's who. So that's one interesting thing. Of course, this program doesn't do much and you can't do too much with the picture. And you have to close it from the command line or else it will never stop. Okay, so here, I'm going to launch just another one of the programs I made. I'll show you guys later if you want to actually see the particular program. And the one I'm going to run is a little bit more interesting. find it. Okay, so I want to open up a window that shows me my topic that I'm interested in. So you guys will boot up a robot, start some software, and you're going to get a ROS topic list like this. Do you have any idea what it means? It's a list of your topics. So there's a lot of topics here. There's a lot of camera topics. There's a lot of camera topics. There's the mobile base commands. Mobile base is actually how you interact with the kabuki. So if I want to tell it how to move, there's a mobile base command velocity, which is right here at the top. That's what I would use to actually set the velocity of the robot. There is this particular topic that I'm interested in. So this is the topic that I need. And you see that I highlighted this line. If you highlight the line, you can use Shift Insert most of the time to insert whatever it was that you highlighted. Here's the standard way to run an image viewer. It is very redundant, but the type of image viewer that we're using is an image view, and it comes from the package image view. So it's very redundant. My program, for instance, was feature tracking, and it was color processing RG. This one is image view package. Just a single program out of the image view package called image view. There's also disparity view, there's other types of views, but they have to be redundant. And then image :equals, and then the topic name. This is very standard stuff. You can find this online, but the topic name will be different for everyone. Now, it's only going slow because we maximize it. Right now we're looking for red. And apparently I need to face this at young gun. Now young gun is highlighted red. I'm sorry, you're the only one in here, and then also this guy's folder is red. So what we're doing here, and it's actually really quick, it just takes a lot of effort on the little computer to send that much in terms of a larger image. You see it's actually really fast. If you move your folder, you might be able to scare it away from focusing only on young gun. And you see he moves and the crosshairs. A little bit lower. I actually have a cutoff height. This is actually a program used to allow a robot to chase a ball. And this is what you get from a project that's just like a couple weeks. Very hard work. We built 4 robots, and we're able to get this squared away pretty quickly. The code I'll show you is probably a nightmare for you guys because it's all C++. And I also wrote all these things out to the image. So what you're seeing here is it's searching for red and recoloring everything that's red into a different color. In this case, it's blue. I can also change it. We have to close the window first. I can change it using this topic right here. ROS topic hub is a command line tool that you can use, but you have to specify what type the message is. And I'll show you a mistake and then see if you guys can figure out what I did wrong. So I typed in standard messages int32, which is a sign integer, 32-bit. But I should have typed in what it tells me to do in the warning. Warning, you typed it in wrong. You should have put this. I'm not going to fix it for you, but you should have done this. That's what ROS tells you. So ROS is really kind to you. So if you come to me and you ask me why it's not working, I'll just read it to you. Especially if it's this simple one line. It's kind of nice. So 1 was actually the same value that we had before. Let's go with 3. You guys don't know what 3 means, right? Nobody should, because it doesn't make any sense. 3 doesn't mean anything. If you had a string, you had state of find blue, I think it's blue, then that would make more sense. So who is blue? Blue, unfortunately, wasn't that good of a color to find.
Nico is blue.
Like sky blue.
So it's kind of spotty. It is wonderful with a recycling bin. It's trained on the color of a recycling bin. So if you have a recycling bin color, it would actually be perfect. Yeah, so it's close. It's not really the best. I can try for yellow, since it's a yellow color.
Yeah, but it's blue. But it's like yours is darker than ours.
So what I'm actually showing you here is all different features you can bake into a program that you probably want to. Sometimes you just need to hit Control-C a bunch of times. Okay, so ROS topic, target color ID, standard messages, UN32. It was fun, but it didn't matter too much. All right, so you want to see some of the code. So here's the modified version of what you had seen there. I'm going to try to get it much larger. I guess here's one thing that my favorite editor does not do. Okay, I'm going to still show you on the command line. So before I told you that you can do a ROS CD, which is a very useful method to just jump right into the folder that you're looking for. So in this case, we wanted to change directory into the feature tracking package that we had created. So I don't know where it is, just get me there. That's the kind of approach that ROS takes. It assumes that you could care less where it is as long as you can get to it. So then you still have to get to the source directory, which is where you put your source code. And here you can do stuff like look at the code. This one is Nano. It's a different editor. And I'm going to show you the Python code first, probably. Since we're talking about Python. And Nano just works in the terminal window. So since we put this user bin environment, it must have typed in wrong in my example. But if we put this in at least, everything will be colored correctly. So here's some mandatory components that you must use for image processing, and of course the image topics in ROS. You need your ROS library. Without the ROS library, you can't do anything. So make sure this is there. Import system, import ROS-Py, import CD2. All these are actually an example online. This is the one with the circle. So here I actually changed it to where I didn't have to type in on the command line when I ran the program what the actual topic name was. Remember, it was image topic 2, image topic 1. That didn't really help us, so I made it to be what it really was. So then, as you can see, there's the publisher declaration, the subscriber declaration, and then the callback, which is where you handle the data. And I must admit, Python is so much simpler than C++ in accessing this portion of doing image processing. And you get all the tools from Python that you wouldn't get normally maybe in C++. So, and you saw I was actually pretty quick at drawing that circle, the little tiny change in pixels on a few pixels. So what it does is it takes the image in, again, draws a circle, shows the window, and then publishes out the new image. So I could have looked at it using a ROS image viewer, and that's about it. Of course, other than managing the program, which is all kind of just standard template stuff that you get anyway. So you can use this as a template if you're doing anything with image data, which is very important to at least like maybe 5 or 10 people there. So with now, to get out of the file, you have to hit Control X. That's this little, here it is, it's a control. So on the bottom left-hand corner, you see exit. You would hit Control X. The other one I wanted to show was the same thing, but it's the same circle basically. Same thing, but in C++. So I know today's on Python, but here's also a reason why you should probably want to use Python if you're scared of C++. So here's the same amount of information that the Python code had. The lines are twice as long, right? There's a lot more obscene characters with ampersand and colons everywhere. A lot more semicolons, of course. That's just basic C++ stuff. And then you go into the callback. They're basically the same. It's just, it takes a lot more effort to write in C++. So after this, I can show you guys the more complicated example, and then go into some more tutorials we can find on ROS.